Hey everyone, I am going to start our class notes on 19.2, which is solving trig equations. These notes should be taken on 318. And so I've uploaded the notes if you want to copy in before watching the video, or if you want to pause the video now and copy the 4 examples down. It might be a good idea to do that so that you can write with me as I go. All right, so solving trig equations is just like solving any other equation. Sometimes we'll solve linear, sometimes we'll solve quadratic, but the whole goal is to get the trig function and the angle alone. So I want to get cosine theta alone. I'm going to do that because these are being multiplied by dividing by -4. What I do to one side, I do to the other. I then end up with a negative divided by negative, positive root 3 over 2, right? We say 2 goes into 2 once, 2 goes into 4 twice. And then on this side, that's going to equal cosine theta. What am I trying to find? I'm trying to find the angles, plural, when we have a cosine value of root 3 over 2. So this is using the hand jive backwards, which we've done before, and most importantly, finding all of the angles. So a few things here. Cosine is x over r. Oops. X over r. So and it's positive, so I'm going to list where I need to be and what angles I need to give. All students take calculus. So I'm going to need to give an angle measure that's in quadrant 1 and an angle measure that's in quadrant 4. So let's make with our hands an x value of root 3. Root 3 for x is going to be here, and we're going to stay in radians. And so then that puts me at pi over 6. Pi over 6 is the angle that I want to use in quadrant 1, and that's one of the ones that I want to give. So pi over 6 in quadrant 1, and so one of my theta values is pi over 6. There's one other spot that I'm going to have a positive cosine value of root 3 over 2, and that's in quadrant 4. Remember, if I have a denominator of 6, I'm going to, in quadrant 4, give the denominator over 6. So reflecting and thinking about a round and counting around 6 pi over 6, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi over 6 is the other angle that I want to give. So two angles, pi over 6, 11 pi over 6, done with example 1. Example 2, same thing goes. I see that this is linear, so I'm going to go ahead and actually, I think this time I'm going to, the first time I worked through it I didn't, but this time I'm going to go ahead and clear my fractions and work to get that cosecant theta alone. So if I clear my fraction and multiply everything by 4, looking at both of my denominators, by 4, by 4, by 4, which again will then give me -6 equals -8. Minus cosecant theta. So I'm going to add over the 8. Add over the 8 to get 2 equals negative cosecant theta. Divide by my -1 to see that I have a -2 value. And I need to find the angle measures when the cosecant is that value. So cosecant goes with sine. We know sine is y over r, so I want to use here, I want to use r over y. So I have to write this as a fraction to see that my y value needs to be 1. My r value is 2, that's in the palm. Also, I'm seeing that I need to find the angles when the value is negative. So I have to think about where is cosecant negative. All students take calculus. And so here and here, cosecant are positive. So I need to give my angle measures in these two quadrants. That's all I do with the negative. So now I just focus on making on my hand a y value of 1 and an r value of 2. That's going to give me an angle here, but then I'm going to reflect and use the two angles that are here. Giving an angle in quadrant 3 and 4 will be my final answer. So if we make a y value on our hand of 1, y is 1, r is 2. Again, putting this finger down puts me at pi over 6 again. But I'm not going to give that as my answer. using pi over 6. I'm not giving that as my answer because I need to give the two that are in these quadrants. So again, thinking through, this is 6 pi over 6, this is going to be 7 pi over 6. So one of my angle measures is going to be 7 pi over 6, and then I know that the one in quadrant 4 that has a denominator of 6 is 11 pi over 6. We just found that in the last one as well. These are the two angles that have a cosecant value of -2. Moving on to example 3, making room so you guys can see. Now this one is different than the last two because it's not just one trig function within the problem. I'm seeing sine, cotangent, I'm seeing another sign on this side of the equation. So my goal here is to do some factoring and bring everything over to one side to make my equation equal to 0 so that I can actually do factoring and use the zero product property. So I'm going to leave cosine x, cotangent x. I'm going to add over the cosine x. So I'm going to put plus cosine x equals 0. This is a term, this is a term, and both of these terms have a cosine x. So I hope you agree that we can factor out what we would say is a GCF of cosine x. When I divide out a cosine x, I'm left with cotangent x plus 1. So I can now use the zero product property to say I need to find cosine x equal to 0, cotangent x plus 1 equal to 0, subtract over the 1, get cotangent x equals -1. Now I need to find angle measures for both of these, so I can have more than just two angle measures that I give. And x is the same as theta, so now I'm just saying I need to find what angle measures have a value of 0 for cosine. Cosine adjacent over hypotenuse, again that's x over r. So I'm going to write this as 0 over 2. So on my hand, I want my x value to be 0, and when I do that, I'm up here at pi over 2. Pi over 2. And so one of my x values, maybe I'll just write it over here. One of my x values is going to be pi over 2, or you can continue to use a theta. Now remember, if we're at pi over 2, our reflection piece, the cosine is also going to be 0 here. Reflect down, and that's going to be 3 pi over 2. So that's another angle measure that I want to give as my answer. 3 pi over 2. Moving on to cotangent, remember tangent is opposite over adjacent, y over x, so I want to use x over y, and making that into a fraction I have -1 over 1. And it's negative, so also I'm going to go ahead and do my all students take calculus. All students take calculus and think about where are my angles that I'm going to give that are negative cotangent. And so tangent and cotangent are positive in these two, so I need to give an angle in quadrant 2 and in quadrant 4. Using my hand, I can't make my y and x just a 1 by putting like one finger down. I need to do here in the middle, because then I have 2, root 2, I should say, over root 2, or root 2 over 2, root 2. So that will give me 1. So this is the finger I'm using. 0, pi over 6, pi over 4. Pi over 4 is what I'm using, but as you can see in our problem, let me get back in focus. Okay, so here we're thinking pi over 4, but we don't want to give in quadrant 1 because we have a negative sitting here. So I want to give the denominator of 4 that's here. I got to figure that out. And I want to give the denominator of 4 over here, so I got to figure that out. So thinking about counting around, right? 1 pi over 4, 2 pi over 4, this is going to be 3 pi over 4. 4 pi over 4, skip 5, skip 6, and give 7 pi over 4. So I'm going to also include over here 3 pi over 4 and 7 pi over 4. Quinn, I'm almost done. You're doing such a good job. Please go away. Thank you. Okay, and the final example, sorry about that. We are going to again see that this is quadratic, and so I have to solve a quadratic, and typically we solve quadratics using factoring, which is what we saw here as well. I see that this is the difference of squares, so I'm going to use sum and difference property. And so I'm going to use tan x plus 1 and tan x minus 1. And so with this, I am going to set each of these equal. So equal to 0, tan x plus 1 equals 0, minus over the 1, tan x is equal to negative 1. Tan x minus 1 equal to 0, add over the 1, tan x equal to 1. So similar to the last, because we had cotangent of 1 and knowing that those are reciprocals, and we had negative there too, more specifically, now we need to find tangent, and tangent again is y over x. And same over here, we need all of the places that it's both positive and negative. So we're going to be giving all 4 quadrants. We're going to be giving all students take calculus. The tangent will be positive here, and we need to give an angle. The tangent is also negative, which is here and here, so that's why we need to give 4 angles. These 2 will be our positive, those 2 will be our negative. To make tangent a positive 1 or a negative 1, right, thinking about the negative piece just with all students take calculus, we're again dropping our root, our pi over 4 finger, right? Root 2 over root 2 will give us 1 for our tangent, so I'm using pi over 4. I'm using pi over 4. I need to use all denominators with 4. Pi over 4, 2 pi over 4, skip. 3 pi over 4, skip 4. 5 pi over 4, skip 6, give 7 pi over 4. 4 answers for x. These are our 4 x values. Okay, I'm going to stop there. If you have questions, you can post in the comment. Thank you. Bye, guys.